and then you just draw triangles, label your triangles correctly, and then go from there as far as multiplying, simplifying, adding, subtracting, combining like terms. So it says requires you to draw a triangle in the correct quadrant. You can't just pick whichever quadrant you want. The situation here is going to tell you what quadrant it's in. Okay, now it's not going to just say quadrant 1, 2, 3, or 4 if it's a sum and difference, but it will give you some information so that you can draw the triangle in the correct quadrant. It is very important that you're in the correct quadrant and you label the sides correctly. How do you know what the sides are? Well, in quadrant 1, x's and y's are positive. In quadrant 2, x's are negative. In quadrant 3, x's and y's are negative. And in quadrant 4, y's are negative. So that's how you know. So if I'm drawing these two triangles, we have a triangle with angle A and a triangle with angle B. So the sum and difference is going to require two triangles. So for my angle A triangle, I have my four quadrants. And the first thing it tells us is that sine of A is equal to 1/2. Okay, so before we pay attention to the 1/2, we have to think about that's positive. There's only two places where sine is positive. The y value is positive up here, so that takes out 3 and 4. And cosine of A must also be positive. Cosine of A is greater than 0. That means we're in quadrant 1. So our triangle with angle A is in quadrant 1. Be sure you label which triangle is which. So if you just label the angle A and B, then you'll be good. Now we also need all the sides. Sine of an angle is equal to opposite over hypotenuse. So opposite hypotenuse. And then a squared plus b squared equals c squared is how you get the other side. So 2 squared equals 1 squared plus x squared, or whatever letter you like. So 4 minus 1 is 3. So x is equal to plus or minus root 3. Since we're in quadrant 1, that's going to be positive root 3. Then over here in this other triangle, it tells us tangent of B. So tangent of some angle, maybe we can figure it out, maybe we can't. Tangent of some angle is equal to 3 over 4. So again, the 3 over 4 doesn't matter when you're picking the quadrant. The positive matters. So tangent is y over x. Okay, it deals with x's and y's. Well, here both x and y are positive. Here one's positive, one's negative, so that's out. They're both negative. Negative divided by negative is positive. And then here that one's out. So it's either 1 or 3 because the signs are the same. Then sine of B is less than 0. Which of those two quadrants is sine negative? 3. So that's how we know we're in quadrant 3. It doesn't matter which one you choose first. If you choose the sine of B is less than 0, you're going to be in 3 or 4. Then this tells you which one it's going to be in. So it doesn't matter which stipulation you pick first to figure out which quadrant it's going to be in. But the information given will only be information for one quadrant. If you think it's 2, then you've done something wrong. All right, so now we can say tangent of this angle is opposite over hypotenuse, opposite over adjacent. Be sure you label with the correct sign. This is very important. This is negative, this is negative. Hypotenuse is always positive. Since we're in quadrant 3, both the x and the y are both negative. That's going to be important for your answer because if you don't do that correctly, then your answer is going to be wrong. All right, so that's the first thing you have to do is get those quadrants or get those triangles drawn in those quadrants. Then you take the sum or difference, whatever's given. In this case, it's the sum, and we expand it. So that would be sine A cosine B plus cosine A, sine B. There it's expanded. And now we actually find the sine of A according to our triangles. We don't know what A and B are. Maybe there's times where we know what A is, but we use the triangles or the information given. We're not plugging in for A and B because we don't know what A and B are. Okay, this isn't 1 right here, so we aren't sure what A is. This hypotenuse is not 1, so we don't know what B is. So sine of A, we look at our triangle. Sine of A is equal to 1/2. So 1/2. Sine of A is 1/2. Sine of A doesn't equal sine of 1/2. Sine of A is equal to 1/2. Cosine of B, cosine of this angle is equal to adjacent over hypotenuse. So -4/5. Cosine of A, back to this triangle, √3/2. And sine of B, back to this triangle, -3/5. So now we just multiply and combine like terms. So over here we have -4/10 minus, because plus a negative, 3√3/10. Because we have a common denominator, we can go ahead and combine those. And there's your answer. Okay, you will always have a common denominator. If you don't, you've done something wrong. So be sure, when you get to this step right here, and these denominators don't match, go back and check your triangle. Make sure you labeled it right. Make sure you found your sine and cosine right, as far as sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. So it requires a little bit of work, but the work involved is not that bad. Just pulling it off the triangle, multiplying, and then combining like terms. And we can't combine the -4 and the -3. This is a 3√3. This is just a 4. Those are not alike. So using the same triangles, cosine of A minus B. Cosine of A, which is √3/2. Cosine of B, -4/5. Sine of A, 1/2, which that was given also. So if the given doesn't match your triangle, you've labeled your triangle incorrectly. And then sine of B, -3/5. Notice that second step right there has no sines and cosines. The cosine of A equals √3/2. The cosine of B equals -4/5. We're done with the sines and cosines at that point. And then notice our denominator is 10. It's 10. So here we have -4√3 minus 3/10. You want to skip that middle step. If you don't want to skip that middle step, -4√3/10 minus 3/10. And then when you combine those, because they're like terms, you get that answer right there. The reason you want to write your answer together like this is because of the next question, the tangent. If it's just separate and you left your answer like this, nothing can be simplified, that'd be fine. There's nothing wrong with this answer. It's just when we do the tangents, you want to keep it together, because if you keep it separate and then you multiply by the reciprocal, it gets to be really, really ugly. It's just nice when you combine it into a single term for when you have the tangent. So the tangent, we don't have a specific identity for that other than our ratio. So for the tangent, that becomes sine A minus B over cosine A minus B. The A minus B's don't cancel, and we're left with sine over cosine. Sine and cosine by itself are nothing. It has to be cosine sine of something. And we can't just write one A minus B. That's not correct either. Now, we just found cosine of A minus B, correct? So we don't have to do all of that again. We just found it. That was this problem right here, letter B. So we can use that in our problem. What we do need to find is the numerator. So sine A, cosine B, cosine A, sine B, and again, over what we just found. We just found -4√3 minus 3 over 10. We already know our denominator. If this had been a plus sign, then our numerator would have been our letter A that we just found. All right, so now again, we're just going to use our triangle up here to fill everything in. So sine of A, still 1/2, cosine of B, negative 4/5, minus cosine of A, root 3 over 2, and sine of B, negative 3 over 5. And so we still have our denominator. So again, these problems take a little bit of time just because there's a lot of work involved, but each little step should not be that difficult. So now notice we have a denominator of 10, a denominator of 10. So our numerator becomes negative 4 plus 3 root 3 over 10 over negative 4 root 3 minus 3 over 10. Okay, so this became our new numerator. Our denominator stayed the same. And now some of you know that when you have a fraction and the denominators are the same, they cancel. If not, go ahead and multiply by the reciprocal. I'll do that step in case you need it. So 4 plus 3 root 3 over 10 times the reciprocal, which is 10, over negative 4 root 3 minus 3. 10 divided by 10 cancels to 1. And we're left with our answer, negative 4 plus 3 root 3 over negative 4 root 3 minus 3. Now, none of those things cancel. There is a plus sign right here, there's a minus sign right here. Because of that plus and minus sign, we cannot start canceling. If those were multiplication symbols, yes, we could cancel away, but they're not. Nothing is alike. This is a 3 root 3, this is a 4 root 3, one's on top, one's on bottom, so there's nothing else we can do to that problem. You could factor, someone earlier said, why do we have all those negatives? You could factor out a negative 1 and cancel it, but all that does is change all the signs. Okay, so you could change all the signs, that's the same thing, but there's no need to factor that out and do that. Question? All right, and then the last example is a double angle. These are a little bit easier because with the double angle, there is only a single angle. So this one does have to tell you exactly what quadrant you're going to be in. It tells you we are in quadrant 2. So we are in quadrant 2. Cosine of A is adjacent over hypotenuse. So 49 equals 36 plus y squared. 13 equals y squared, so y is plus or minus root 13. Left is negative, up is positive, so it's going to be positive root 13. Now, sine of 2a, there's only one way to expand that. 2 sine a cosine a. We cannot do anything with sine 2a because we don't know what the angle is. Here's angle A. All I know is that's angle A, somewhere between 90 and 180. I don't know what it is. It doesn't matter what it is. I want to know what the sine of A is and the cosine of A. So, sine of A is opposite over hypotenuse, so I have 2 times root 13 over 7 times negative 6 over 7. And so now it's just multiply. Multiply across, negative 12 root 13 over 49. Common mistake is to put 7 in your denominator right here. Now we're multiplying. The last problem we were adding and subtracting, so the denominator stayed the same. If we're multiplying, you multiply just across. So 7 times 7 becomes 49. If we were adding and subtracting right here, then yes, the denominator would say 7. But we're multiplying, so we actually multiply them together. Now, cosine of 2a, there's 3 different ways to write that. You can pick whichever way you want. I personally like to use cosine squared a minus sine squared a. But again, it doesn't matter. All 3 of them will get you the same exact answer. And if you want me to show you all 3 of them at the end, I'll be more than happy to do that. Now remember, what this means is cosine A squared minus sine A quantity squared. We are not squaring the angle, we're squaring the whole value. We're squaring the value of cosine A and the value of sine A. We aren't doing anything to just the A value. So what that becomes is negative 6 over 7 squared minus root 13 over 7 squared. So that's 36 over 49 minus 13 over 49. Again, you will have a common denominator. If you don't, you have made a mistake somewhere. You're not going to have to get a common denominator. It will already be there because we're dealing with sines and cosines, and the denominator is always the hypotenuse, and the hypotenuse isn't changing. So we get 23 over 49. So now we are subtracting, so that 49 stays 49. Here we were multiplying, 7 times 7 is 49. Here we're subtracting, so that denominator stays. And then tangent is equal to sine 2a over cosine 2a. A little bit easier than the last one because we've already found both of those. We found sine of 2a to be negative 12 root 13 over 49. And we found cosine of 2a to be 23 over 49. So we multiply by the reciprocal, we get negative 12 root 13 over 23. So the answers aren't always that pretty. They might have roots in them. If your original problem, your triangles don't have roots, then obviously your answers aren't going to have roots, and so you can multiply things together, add and subtract a little bit easier. But there could be something that is a little bit ugly. If you have a radical in the denominator, you can rationalize if you want, but you don't have to. Okay? We do not require you to rationalize, so if you end up with a radical in the denominator, it's okay, you can leave it there. But just know you'll still have a common denominator as far as adding and subtracting goes. All right, anything?